Hey everyone, today we're diving into the life of a true math superstar, Guillaume de l'Hôpital. This guy was super important in shaping how we understand calculus. Born into a fancy French family in 1661, l'Hôpital lived during a time of huge scientific discoveries, the scientific revolution. It was a time when people were figuring out all sorts of new things about the universe, and math was a big part of it. L'Hôpital, with his awesome textbook and his famous rule, became a key player in this math revolution. He didn't just make discoveries himself, he also helped make calculus easier for everyone to understand. So let's explore the life and work of this influential mathematician, from his noble beginnings to his pioneering work in math. We'll also look at his important contributions, including his complicated relationship with another mathematician named Johann Bernoulli and the lasting mark he left on the world of math. Born into a life of luxury, l'Hôpital was expected to join the army, just like other young men from rich families, but l'Hôpital secretly loved math. What started as a hobby soon became his main passion, leading him to ditch the army and dive headfirst into the world of numbers. He became totally absorbed in math, studying the works of famous mathematicians and keeping up with the latest discoveries. His dedication caught the eye of some big names in math, including a super smart Swiss mathematician called Johann Bernoulli. One of l'Hôpital's most famous contributions is something called l'Hôpital's rule. It's a really useful trick for figuring out limits that look confusing at first, like 0 divided by 0 or infinity divided by infinity. These tricky limits pop up all the time in math, and they can be hard to solve. L'Hôpital's rule makes things much simpler by looking at the slopes of the functions involved. It's like a shortcut. This rule is a lifesaver in calculus, making it easier to solve limits and understand how functions behave. In 1696, l'Hôpital published his super important book Analyse des infiniment petits pour l'intelligence des lignes courbes, which we can just call Analyse des infiniment petits. This book was the first real textbook on differential calculus, and it helped spread this new type of math like wildfire. Before this book, calculus was mostly a secret, shared only between a few mathematicians. L'Hôpital's clear and simple writing, with lots of examples, made calculus accessible to everyone, including students and scholars who were excited to learn this new math tool. Analyse des infiniment petits became the go-to calculus textbook for many years, cementing l'Hôpital's place in math history. Section 5, Calculus in Action, Geometry and Beyond. L'Hôpital didn't just develop and popularize calculus, he also used it to solve problems in geometry and other areas. He did some cool work on finding tangent lines to curves, a basic problem in geometry, showing how useful calculus could be. He also explored differential equations, which look at equations with slopes. This showed how versatile calculus is for understanding change and movement. L'Hôpital's work set the stage for other mathematicians to use calculus in physics, engineering, economics, and lots of other fields. Section 6. A controversial collaboration, l'Hôpital and Bernoulli. L'Hôpital's relationship with Johann Bernoulli, although important for his math development, wasn't without some drama. In 1694, l'Hôpital made a deal with Bernoulli. He would pay Bernoulli so that Bernoulli could focus on his research, and in return, l'Hôpital got to use Bernoulli's discoveries. This seemed simple enough, but after l'Hôpital died, Bernoulli claimed that many of the results in Analyse des infiniment petits, including the famous rule, were actually his own. This claim, although debated by some, has created some mystery around l'Hôpital's work, raising questions about who really deserves credit. Section 7. The power of patronage. The controversy around l'Hôpital and Bernoulli shows us how important sponsors were for scientific progress back then. In the 1600s, there wasn't much money for science, so researchers relied on rich patrons for support. L'Hôpital's wealth allowed him to give Bernoulli the financial security he needed to do his research. While the fairness of their agreement is still debated, it shows how complicated scientific partnerships can be and how important sponsors were in shaping scientific discoveries. Section 8. L'Hôpital's enduring legacy. Even with the controversy, l'Hôpital's contributions to math are still really important. His textbook Analyse des infiniment petits helped make calculus much more popular and understandable. L'Hôpital's rule, whether it was all his or a team effort with Bernoulli, is still a fundamental tool in calculus, used by students and mathematicians everywhere. Plus, L'Hôpital's work on applying calculus to geometry and differential equations opened doors for new math techniques and their use in different fields. His work shows how powerful calculus is and how it has changed math and science. Section 9. Conclusion: a catalyst for mathematical progress. Guillaume de L'Hôpital's story, from nobleman to math pioneer, shows the intense curiosity and love of learning that defined the scientific revolution. His contributions, especially his textbook and his famous rule, helped make calculus accessible to everyone, helping it grow into a fundamental tool in math and science. While the questions about his work with Bernoulli remain, it reminds us that scientific teamwork can be complicated and that sponsors played a big role in scientific progress. L'Hôpital's legacy isn't just about his own work, but also about how he helped advance calculus and its lasting impact on how we understand the world.